Hello guys and welcome. I hope that you're doing well. My name is UHDking or I play 4K, aka I play 8K, aka I play 16K, and during this video I'm going to demonstrate world's record. I'm going to run Shadow of Mordor, Middle Earth PC game in 16K video resolution. 15,360 pixels by 8,640 pixels or 132.7 megapixels rendered in real time. Okay, that is 16K UHD, 16 divided by 9 aspect ratio, 16K gameplay, 16K gaming, 16K video resolution benchmark. Okay, so now you understand why UHDking. I already demonstrated for the first time in the world native 16K video resolution in Shadow of Mordor PC game that was released in 2014. The game from 2014, it's almost 10 years, but it's beautiful looking game in June 4th, 2023. Today is June 4th, 2023. It's early in the morning. It's almost 6 a.m. I just woke up. Let me zoom it for you. As you can see, I'm using the magnifier zoom tool a lot. Okay, and when I'm running above 8K video resolution benchmarks, tests, gameplays in the desktop, I'm using a lot Microsoft magnifier zoom tool. Check it out, 700% zoom, how clear everything is. Yes indeed, we are running baby 16K UHD. But anyways, before we're going to start the benchmark, before I'm going to open up the game for you, I already demonstrated, by the way, for you back in 2021 on my Xeon E5 2697 V2 CPU. It's socket 2011 for the chipset X79 while I was running single Titan RTX video card by Nvidia Turing GPU architecture TU102 GPU equipped with 24 GB of video RAM. Today I'm going to use much faster CPU, which is Core i9 9900K overclocked at 5.1 GHz while running 8 physical cores, 16 logical cores or 16 logical threads while hyper-threading technology is enabled at 5.1 GHz per core and 5.1 GHz AVX2 instructions, so it's going to be synchronized with 32 GB of DDR4, 3200 MHz, but CL11 1T command. So it's equals to DDR4 5000 MHz, CL18, and maybe above of that. I'm about to test it to find out which scenario is better. DDR4 3200 MHz CL11 versus DDR4 5000 MHz CL18. But today is about 16K UHD, 16K gameplay, 16K gaming, 16K video resolution, guys, benchmark. And yeah, so this is the system. All right, let me real quick go ahead and go with you. It's a ASUS Z390 chipset motherboard, Maximus 11 Hera. It's running 8X PCI Express Gen 3 per each slot on each Titan RTX 8X Gen 3, okay? Memory, as I told you, 1600 megahertz times 2, 3200 megahertz output, CL11, 1T command, dual channel, 128-bit, but 4 sticks, 8 gigabytes for the maximum possible bandwidth. No matter if you're running cheap DDR4 or most expensive DDR4, it's still going to be the maximum possible output if you're going to use 4 sticks, 8 gigabytes, the best possible scenario for dual channel, even if it's also capable to run quad channel 256-bit because it's 4 sticks, but dual channel 128-bit will be the best possible scenario, no matter how many banks you're running on your chips on DDR4 sticks, single bank or dual bank. All right, as again, Corsair 5000, 2500 megahertz times 2, 5000, CL18, but this is the Micron chips, not Samsung B chips. Samsung B chips doesn't like the latency, low latency is the key, the low number, but higher frequency is the key as well, but it loves high frequency. But Micron technology chips on DDR4 doesn't like high frequency but loves low latency. So I think I utilize my memory the best possible, 3200 megahertz CL11 1T command. And this memory, by the way, Corsair DDR4 5000 megahertz CL18, unstable on this motherboard above 3800 megahertz no matter what is the latency, okay? And I believe the reason why, because it's Micron chips, and I think Corsair is lying. They told me it's only supported on MSI carbon fiber Extreme Edition Z390 motherboard only, because I tested on Gigabyte Extreme Z390, on ASUS Maximus Hero Z390 11. Doesn't work, guys. Okay. But I'm going to test it when I'm going to retire this i9-9900K Intel Gen 9 CPU to Intel Gen 13 CPU on a Z590 chipset that's going to support DDR4 technology, so I can utilize this very expensive memory that I got. It was like $1,000 per 16 gigabytes. I got two of them for $2,000, 32 gigs, just for you guys. So don't forget to smash that like button. A lot of time, money, energy is invested just for you, so we can do all the computer science. But today is about 16K video resolution, alright? So let's go ahead and keep moving. So two Titan RTXs. Here we go. The best possible system for the SLI, most likely, especially when it's overclocked to the maximum, because the Gen 12 and Gen 13 Intel CPUs doesn't support SLI certified on the motherboards. Okay, it's certified for Crossfire, but for multiple AMD Radeon video cards, but not certified any longer for Nvidia multiple video cards, because Nvidia discontinued SLI technologies. Due that SLI technologies is supported only for DirectX 9, DirectX 10, and DirectX 11 API, and newer games will be utilizing DirectX 12 API and ray tracing that doesn't support the SLI technology. Okay, but it supports multiple GPUs, keep that in mind, but developers doesn't utilize it at all. So Nvidia decided to drop the support of the SLI, but this is going to be the latest mammoth, the latest dinosaur that supports SLI, Nvidia SLI 2-way SLI technology as a gaming video cards with the full features of the SLI technology. It's not like a quadra SLI support, it's a real gaming SLI support while utilizing all GPUs to the 100% if possible, if your CPU is capable without bottlenecking to handle those video cards. At least this CPU is capable to handle GTX 1080 Ti's and SLI at 99% utilization, which is the Pascal GPU architecture, and two Titan XPs, which is the Titan X Pascal GPU architecture and SLI at 99%, but it's not capable to handle two Titan RTXs and SLI fully utilized, while zero Nvidia Turing CUDA cores are idling, and I will explain to you throughout this video. So this video will be informative as possible. This video is not going to be as fast as possible, so this video will be a little bit over 1 hour. I'm going to cover all kind of different video preset under 16K video resolution. We're going to talk a lot technical. I'm going to share a lot of information, tips, tricks as 3D artist, graphics designer, PC gamer, PC hardware enthusiast, system engineer, software overclocker, game developer. So a lot of information will be shared, guys. And PC overclocker, of course. So I'm going to jump into 100% fan rotation. It's synchronized per each video card. I'm not going to overclock it because the first video card, let me show it to you, by the way, on the picture right here, it's the first video card right here to the CPU is going to get so hot because there is no space between them to breathe, and it's going to overheat. It's going to thermal throttle, and thermal throttle starts after 59 Celsius on Nvidia Turing GPU architecture, and when it's going to reach 88 Celsius, it's going to drop by 400 megahertz, and it's going to drop the voltage, wattage, while it's going to start cooling itself automatically through the artificial intelligence, through the software developed by the Nvidia. Such a great company. Kudos to Nvidia. They did a good job. So you're not going to burn out your video card, all right? So that's the reason why I'm not going to overclock it. As you can see, Shadow of Mordor is licensed under the Steam, so we're going to use the Steam version. As again, I already recorded world record, the first world record, 16K UHD in Shadow of Mordor, but it was on single Titan RTX video card, and the CPU was much slower. It was from 2014 X79 chipset, as again 2697 V2 2011 socket, and today we are using the i9 Gen 9, and it's a 9900K. Okay, and it's that CPU was 3.5 gigahertz. This one is 3.6 from stock, but core per core, clock per clock, the i9-9900K delivers much higher instruction per clock. Keep that in mind. So for the Xeon E5 2697 V2 to reach this i9-9900K, I think it must be overclocked to like 4.95 gigahertz, but it's not overclockable. But anyways, that CPU delivered 16 lanes on a PCI Express Gen 3, and today I'm running a PCI Express Gen 8X per every single video card, per every single slot. All right, so before we're going to jump in, let me show to those naysayers, to those haters, that indeed I'm running the SLI right here. What's the point for me to lie? My reputation in that. Okay, and I hacked the Nvidia driver because I'm outputting to 8K UHD, but I hacked the Nvidia driver through the system RAM debugger tool and Windows 10 professional operating system. So Windows 10 professional operating system and Nvidia driver is thinking that this is a native screen, 16K UHD, but it's not. Okay, and but it's acting like that. But I hack it. I'm using the Nvidia DSR, the old school legacy DSR, without any artificial intelligence yet. They introduced kind of newer DSR, but DSR is not DLSS. Keep that in mind. DLSS is upscaling. DSR is not upscaling. But newer DSR, using the artificial intelligence, doing such a great job while using artificial intelligence, because it's delivering much higher FPS for the same results. But the old school legacy DSR that I'm using today, that is available on Maxwell GPU architecture, Pascal GPU architecture, and Turing GPU architecture by Nvidia, such as Titan X, Titan XPs, and Titan RTXs, is going to be old school and is going to be rendered in that high resolution and then downscale and output to the cable to your screen. But it doesn't matter where it's outputting. The downscale process takes like 1% of the GPU performance, while doing image processing on the GPU is just so fast on that resizing, not even 1 FPS loss. But this is what it is, all right, and it doesn't matter what it's outputting, it's still going to render in that resolution, that native resolution, 16K UHD, 16K video resolution, and you will see it. So recognized by the Nvidia driver, my as you can see, as 15360 by 8640. Okay, it doesn't say DSR legacy. If you're gonna do it through the DSR, it's gonna say DSR or DSR legacy. It doesn't say so because I confused the Nvidia driver completely. So it's thinking this is a native resolution, 132.7 megapixels per every single frame is going to render in 3D in real time. 15,360 pixels by 8,640 pixels. Okay, otherwise it should say DSR legacy or DSR, which is newer DSR with artificial intelligence, but only available for the RTX 40 series video cards, such as RTX 4090, RTX 4080, RTX 4070, and RTX 4060, which is Nvidia ADA GPU architecture. The legacy also is available for the RTX 30 series video cards, such as RTX 3090, RTX 3080, RTX 3070 video cards. All right, so what we're gonna do, let me show you my drivers real quick for those who's curious, the presets of my drivers. But pretty much I didn't do anything, but you can create a profile. I didn't do anything. I used the Nvidia SLI ready profile as a global settings, and it says maximum performance. This is very crucial to set power management as maximum performance, not as adaptive, not as optimal power, but maximum performance. So you're going to deliver the maximum voltage and you're going to stress the GPU while utilizing every single CUDA core of that Nvidia Turing GPU architecture. Okay, also important thing, SLI rendering is Nvidia recommended for this particular game, Shadow of Mordor. It's scaling SLI, but if it's not going to scale the SLI, then if you're going to switch, let's say in the future, if you're going to switch to force alternate frame rendering 2, which is AFR2 short, and even under Nvidia driver, you don't need to use the Nvidia inspector. It's going to render it as SLI. All right, this game is ready, guys. It's developed beautifully. The game developer for this game did a good job. They put their souls in it, and I'm not sure why this game is not so popular. It was released in 2014, but the visuals in 2023, as again today is June 4th, 2023, is looking unbelievable. But keep in mind that 16K UHD video resolution in this particular game was available to us since December 2018. 2018 when Nvidia released to the public for sale Turing GPU architecture and Titan RTX video cards. All right, keep that in mind. Since 2018, but I was so busy while recording all the 8K, 10K, 12K, 16K UG video gameplays over the UHDking.com, so I didn't utilize this game. But I did a lot of games, so go ahead and check out for more 16K video resolution gameplays, UHDking.com or 15,360 times 8,640.com projects. All right, so this is kind of the thing that I'm going to use. For those naysayers, also display settings, my display settings, let me show it to you. Look at this, 1200% Windows magnifier zoom tool. Go ahead and try to do something like that on your 4K UG monitor. Everything will be so pixelated. Over here everything is so sharp, 100% scale. All right, and 15,360 by 8,640 pixels, that is 132.7 megapixels, or 16K UHD in 16 divided by 9 aspect ratio. All right, let me go ahead and zoom out. Let me go ahead and close that, and let's go ahead and execute the game, guys. Throughout the game I'm going to share a lot of valuable information as well. Yeah, let's go ahead and execute the game now. Let me start the fan. I'm going to put the fan at 100% on the MSI afterburner, and that's it. It's synchronized. I showed you everything what you need to know. By the way, under the bench, this is how this CPU scored. When you're running i9-9900K over 5 gigahertz, you gotta use 1.41 volts to keep it stable, or at least 1.4 volts. And it's thermal throttling even on the Corsair H150i, okay, which is 360 millimeter radiator, water cooler, and 3 Corsair fans. It still cannot cool it down. It's going to thermal throttle even with the liquid metal thermal compound paste by thermal grizzly. All right, I also using the liquid thermal compound paste on the GPUs by thermal grizzly, so GPU 1 and GPU 2, and RTX silver thermal compound paste on pads on the video RAM GDR6 by Samsung. All right, so everything was explained. Let me execute the game. I'm coming in real time, which is the best possible experience, guys. And we're gonna go as we're gonna go. I didn't test it with two-way SLI yet. I just ran twice just to see if it's runnable or not, and then I decided to go ahead and share it with you. I just woke up sipping some hot coffee with the organic honey in it, and this video is going to be legendary. So as part of my 16K UHD, this is the world's first while using 2 video cards, 16K UHD, guys, and the last dinosaur, the last mammoth, because the Titan RTX is fully gaming video card supporting SLI feature as gaming video cards, not like a Quadro like SLI, just like Titan Voltas or Titan RTX 3090 or Titan RTX 4090. Those support SLI as quadrants. This is support SLI as gaming video cards. A little bit different thing. Just like Maxwell did, supporting SLI as a gaming video card. Pascal's did. Alright, so it's running full screen, 16K maximum visuals, and it is through that maximum visuals. Let me tell you 1 FPS. It's kind of lagging. So while I'm not recording with Nvidia Shadow Play, it doesn't lag at all, and it's not like 1 FPS. Look like while I'm using Nvidia Shadow Play recording in 8K UHD at the same time, and as again Turing GPU architecture supports encoding 8K UHD in Nvidia Shadow Play, but you gotta hack your GeForce experience. Otherwise, Nvidia unlock that in the either GPU architecture RTX 40 series video cards such as RTX 4090, RTX 4080, RTX 4070, and RTX 4060 video cards generations, and through the AV1 codec. Okay, somehow they didn't unlock this in Turing or Ampere GPU architecture such as RTX 30 series video cards, but Titan RTX is RTX 20 series video cards. Keep that in mind. So while I'm using the Nvidia Shadow Play, it's very heavy on the video RAM utilization, look like a little bit heavier, and 1 FPS versus 13 FPS while not using Nvidia Shadow Play. So look like this game engine and this particular game doesn't like Nvidia Shadow Play recording in real time. But let's see what we can do real quick, guys. In the video comments, I'm going to put that test on a Xeon E5 2697 V2 on a single Titan RTX video card, but performance will be twice while using Titan RTX and SLI. But go ahead and have a look, because that video card was running 16x PCI Express Gen 3, but as again, it doesn't matter for Gen 3 and for the Titan RTX or Turing GPU architecture. 8x or 16x, you're going to be Gucci. 4x kind of matter, but 8x or 16x, you're gonna be Gucci. So what I'm gonna do, first of all, the game is set to 16K video resolution, not through some scale like those naysayers and copycats doing, because they cannot copy me properly. They doing the percentage. This is not the percentage. This is a native resolution set under the video. Let me show it to you. As you can see, 1 FPS is kind of slow. I'm apologizing for that. It's running full screen, but it doesn't matter. Full screen or Windows mode is still gonna do that. This game has no problem. It doesn't flicker in full screen, as you can see. Almost doesn't flicker in full screen. So I'm gonna run it in full screen, because the previous test on the Xeon E5 2697 V2 and a single Titan RTX video card, I did full screen. So as you can see, 100% scale, very important. 100%, not like 4K with 400% or something like that. 100% scale, 15,360 times 8,640. This is the resolution. That is exactly as our desktop set, exactly as Nvidia driver is set as well. Let me escape that. We go to the advanced now. Yeah, it's gonna be struggling while I'm going to run the maximum visuals. I'm going to start with the maximum visuals, and then we're gonna lower it down. Okay, so under the advanced settings, I believe it's set to the ultra preset, completely ultra preset. Let's go ahead and have a look. And as again, it doesn't do that if I'm not recording with Nvidia Shadow Player, but I want to demonstrate for you the 8K video resolution as well. So this video provides multiple value, no matter what kind of industry you're coming from. PC hardware enthusiast, system engineer, gamer, 3D artist, graphics designer, game developer, software developer. You're going to learn a lot by watching this video, because this is the world's first 16K UHD in this particular game, Shadow of Mordor, while using 2 video cards in 2-way SLI by Nvidia. So motion blur, let's go ahead and try to shut down the anti-aliasing. Let's go ahead and have a look if it's going to help. So this is ultra preset untouched, but what if I'm going to shut down the anti-aliasing? FXAA pretty much is nothing for Turing GPU architecture. It even doesn't recognize that. But let's go ahead and try to shut it down. Now let's go ahead and have a look if it's going to help or not. I'm going to apply that, and if you can run it or not without the anti-aliasing. Because I ran the test at ultra without the anti-aliasing. I just did it. It was 13.7 FPS, keep that in mind, which is exactly double, a little bit over double than a single Titan RTX did on the Xeon E5 2697 V2 CPU, because that CPU showed 6.7 FPS on a single Titan RTX. So SLI shows some advantage, as you can see, a lot of advantage actually. So we apply that. Let's go ahead and have a look what it's going to be. The video RAM is crazy. Yep. Okay, we improved. So we get rid of the, look like this particular game engine doesn't like Nvidia Shadow Player while it's running the anti-aliasing. Alright, that's Gucci. We're Gucci. Anyways, so ultra preset, but without the anti-aliasing, went to custom, but at least we can test it now, and it's benchable experience, because before even wasn't benchable. But keep in mind, under 16K video resolution, 2 Titan RTX video card, Turing GPU architecture by Nvidia, in 2-way SLI is capable to deliver playable experience, but you gotta lower your settings, and I'm gonna demonstrate it for you as well. So as again, this is the first data, the first vertex, the first coordinate towards the 16K UHD, 16K gameplay, 16K gaming vector direction, guys. So don't forget to smash that like button, and especially if you Shadow of Mordor PC game fan. And by the way, this game is amazing. I'm not sure why this game is not so popular. This game is amazing. The visuals from the game in 2014 is amazing. It has great visuals, especially when you're playing in 8K UHD. By the way, I'm gonna demonstrate for you 8K UHD. Unbelievable experience on 2 Titan RTX and SLI. It will be available over UHDking.com or iPlay8k.com. Go ahead and check it out. The game is amazing and it has a great story. I'm also going to show you the Shadow of War, which is the second part of this game that was released, much newer game, and that one is on another level as well. But even this one is a great game. If you're smart, you can pick up this game below $10. I gave away about 10 of those games, including this Shadow of War, over UHDking.com YouTube channel as giveaways throughout my videos, benchmarks, and as well as throughout the holidays to my subscribers, to my followers. This is another reason why you want to like this, support me, and subscribe, guys. I'm showing you the future 2030, but a lot of people doesn't understand, and I'm so honest with the good morals regarding the computer science. So average FPS 14.6, which is over double than a single Titan RTX did on Xeon E5 2697 V2 CPU while running 16x on PCI Gen 3, while right now I'm running 8x on PCI Gen 3 per video card. Okay, so as you can see, it doesn't matter. But that CPU is slower, I would say, by as minimum 30%. But as again, it's not going to even giving you 2 FPS extra, as you can see. So indeed, Nvidia SLI technology is showing some great advantage. And keep in mind, guys, that I'm coming in real time. I'm not reading this information. So as we're going to go, it's going to be the best experience to share while coming in real time. So average FPS 14.6, maximum FPS 18.1, minimum FPS 11.7. And this is ultra preset without anti-aliasing. Okay? 2 Titan RTXs and SLI. Beautiful. By the way, video comments, I'm going to put all the related videos. In the future, I'm going to use this game a lot while testing PC systems, video cards, CPUs, and even mobile devices, mobile chips, like iOS chips and Android chips, tablets and phones. So this is going to be a great test, guys, and we're going to use it in the future. This game, I really like this game. CUDA to developers. They develop a beautiful game. As again, I'm not sure why it's not so popular. I'm a big fan. Too bad I don't have a time to play it too much, but big fan of it, especially in 8K UHD. Since for Titan X Maxwell GPU architecture in 4-way SLI, my quad SLI setup in 2016. And yeah, this game is amazing. And CUDA to developers to develop a benchmark. They did a good job. All right. So what I'm gonna do now, we look at the Ultra, right? We saw the FPS. Keep in mind that I'm recording with Nvidia Shadow Play on the same computer, so it's utilizing about 7% of the FPS. So not even 1 FPS, but almost 1 FPS you can add without Nvidia Shadow Play recording. So I'm going to show you very high now. Okay, let me go ahead and apply that, and I'm going to shut down the game. I'm going to reboot the game just in case. Close the game and reopen the game. So we're going to clean the video RAM garbage collector, because I believe this game has some issue, the game engine. And it crashed by itself, by the way. Okay, that's good. Is it? Or it's running on the background? There's something running on the background. Let me double check. Yeah, the game is still running on the background. Here we go. But let's go ahead and see if it's going to apply. Hopefully it's still recording. This is going to be a single take. I'm not going to edit this video. Please keep that in mind. Alright, so I believe it's like the FPS is like 0.1 FPS, and it will take some time to update. Okay, here we go. Still recording. I can see that little icon at the bottom right corner, Nvidia Shadow Play. So I'm gonna quit the game now, okay, and we're gonna load it up again, and I'm going to disable the anti-aliasing when we're gonna do so. Let's go ahead and I'm gonna go ahead. It's apply the settings. Let me go ahead and close it down. Okay, it's flickering a little bit. Still applying that, as you can see. All right. So what I'm gonna do, I'm just going to Let me see. So 16K video resolution, that's crazy, guys. I'm going to go ahead and close it. Here we go. Come on, come on, come on. I'm going to close it, reopen it. It's going to clean the video RAM garbage collector, and we're going to turn down the anti-aliasing, and we're going to run the very high test, then high test, then medium. Medium will be fine. And let me see. And after that point, I'm going to test the low and lowest. So every single preset will be tested just in case. As you can see, just because 0.1 FPS, I think it happens because we overloaded our 24,768 megabytes of the video RAM, and we are loading some information into the system RAM, and system RAM today, as you saw, 50 gigabytes per second data bandwidth, while the video RAM data bandwidth GDR6 that is equipped on Titan RTX by Samsung is 680 gigabytes per second, which is over 12x in terms of the bandwidth that it can push. So 12x, my DDR4 is slower than my GDR6 of video RAM. So that's why, and when it's offloading some data and then when it's calling the data, that's why it happens like this, guys, and it's low. And when you see something like that and crazy latency delay at the left top corner, the milliseconds, ms stands for the milliseconds. It's a latency delay before each frame is rendered. Okay, so it's like almost 1000, even 4000 milliseconds, which is 4000 ms. See that by the fps, frames per second, on the right. That means that that's a clear sign that you're offloading some data. Instead of loading it by the GPU through the level 3 cache into the video RAM, you're loading it into the system RAM, and system RAM is not fast enough and it cannot handle that. Hopefully, guys, this makes sense. So, okay, so we done that. Let me go ahead and execute it again. So, very high. We rebooted the game. It's gonna clean automatically by the Nvidia driver, the garbage collector, everything what the game engine created. I did it as a game developer, software developer, just in case, okay? With a dozen years of experience as a gamer as well. After the high preset, everything will be so fine, because ultra, very high and high preset is using the anti-aliasing, and somehow this game engine is not friendly with Nvidia Shadow Play and anti-aliasing. Keep in mind that it doesn't happen like that when anti-aliasing is not enabled. Oh, right now it's fine. Look at this. I even don't need to disable the anti-aliasing. So we are now going to disable the anti-aliasing in this case. Okay, as again, video 100%, 15,360 pixels by 8,640 pixels. That is 132.7 megapixels. Okay, full screen, no limit on FPS. So maximum FPS. So advanced options. Titan RTX running stock as again, but 100% fan rotation there is synchronized. Very high preset completely. This is the preset. As we said, let's go ahead and benchmark it. Nvidia Shadow Play is the technology that utilizing the hardware capabilities of the Titan RTX video card or any Nvidia video cards that is supported while it's running on the same computer. So it's a little bit stressful condition already under 16K video resolution. That is the maximum video resolution for any kind of 3D rendering real-time APIs, commercial or open source. By the end of this video, I'm going to demonstrate it for you as a fact, But anyways, beautiful game, guys. It's looking absolutely amazing. I cannot wait to test it, but keep in mind that two Titan RTXs scaling like this above 90%, that's pretty much RTX 3090 performance, maybe RTX 3090 video card will be a little bit faster by hair, but RTX 3090 Ti maybe will be 10% faster than this, maximum 15% faster, 15% faster. But RTX 4090 video card, either GPU architecture by Nvidia, if it's going to utilize at 99% as our secondary video card, it's going to deliver 4 times performance versus single Titan RTX video card. At least 4 times performance, guys, because it's delivering, when it's utilizing 99%, 2 times performance over RTX 3090 video card. And RTX 3090 delivers 2 times performance over single Titan RTX. That means that we're going to be here around 24 FPS with the RTX 4090, 22, 24 FPS. So hopefully RTX 50 series video card flagship by Nvidia, such as RTX 5090, hopefully it's going to be equipped, by the way, with the 36 gigabyte of video RAM as minimum, GDR7, or 48 gigabyte of video RAM, probably 48 gigabyte of GDR7, will deliver 30 FPS. But as again, I'm going to use this game as a benchmark for the future. This is the first data, the first coordinate towards 16K video resolution, 16K gaming, 16K gameplay vector direction. All right, and UHDking was the first YouTuber that showed you guys ever on YouTube since 2015 16K gameplay, and 16K gameplay on Nvidia video cards since 2016. Before the Linus did, before the Linus Media Group did, I did it with my 4 Titan X Maxwell GPU architecture. Anyways, average FPS 14.6, maximum FPS 17.9, minimum FPS 11.7. Okay, 2 Titan RTX is very high preset. Great, great, great. Let's go ahead and keep moving. Now we're gonna have a look at bench high preset. So this is probably the best possible scenario for the 2 Titan RTX video cards in SLI. You can squeeze a little bit farther with the Intel 11 Gen, the last CPU that supports SLI certified on some of the motherboards, unlike Gen 9 or Gen 10 supports almost on any motherboard SLI support, while Gen 11 Intel CPUs supports only on few motherboards, and Gen 12 and Gen 13 Intel processors doesn't support SLI certified on motherboards. They support Crossfire only, AMD multiple Radeon video cards, multiple AMD Radeon video cards. All right. So, all right. So let's go ahead and switch now to high. We're gonna go ahead and save that, apply those settings. Guys, if it's going to stop recording, we're going to be done. Hopefully it's not going to stop recording, because this is going to be a single take. So it's applying. We gotta wait a little bit. It's still applying. Here we go. It's applied. As you can see, Titan RTX has actually 24,832 megabytes. This is what game developers pull up by the game engine. Most likely they're getting this value through the DirectX 11 API class. They pull the variable value, and this is what it is. Our video RAM capacity in terms of the megabytes. It's 24 gigabyte of video RAM, but in terms of the megabytes, it's 24,832 megabytes exactly allocated for our PC games rendered in real time. Okay, as 3D scene, 3D canvas, or 3D world, depends to the API that utilizing that game and the game engine. Anyways, high preset. Let me go ahead and reboot the game just in case. As you can see, we increase in terms of the FPS, but I'm gonna reboot the game, so we're gonna deliver a fresh system RAM and video RAM utilization in terms of the usage, and we're gonna clean the garbage collector just in case, because I'm afraid that game engine is not properly cleaning the garbage collector, because it's runnable under the Ultra without Nvidia Shadowplay, and it's not runnable under the Ultra within the Nvidia Shadowplay. So there is some problems, and Nvidia Shadowplay didn't give me any problems. Didn't give me any problems in any other game. So this game engine has some problems, some issues. So you saw how small that Steam icon was at the right bottom corner. It was just tiny, tiny, tiny. Guys, don't forget to smash that like button for support. A lot of time, money, energy is invested, and as you can see, I'm covering as a first YouTuber, as pioneer. We're gonna go through the troubleshooting with you together, through everything. All the information is covered and delivered to you honestly the way it is. This is the real deal, guys. Support me. I'm putting my reputation on it, my time, my energy, my money. Support me, guys, and we're gonna dedicate more time towards the computer science. We're gonna do some crazy stuff, unique stuff, not like one of those copycats that copy each other on YouTube and providing no values. Anyways, as again under the video, 50,360 by 8,640, 100% scale, no limit on FPS, full screen. Full screen is supported without flickering on our SLI, which is great. High preset, untouched. Alright, let's go ahead and run the benchmark. Look like the FPS is going to be almost like a very high because the game menu is using the 3D canvas. As you can see, it's not a 2D image under the menu. This image is still 3D, so it's delivering the actual performance of the game engine. The whole menu can be used as a benchmark. Look how beautiful this game looks like. Guys, I'm going to deliver for you 8K, 10K, 12K video resolution on single Titan RTX and two Titan RTXs and SLI on the Intel Core i9-9900K. And it's going to be available over the UHDking.com to study some more information and data. Go ahead and check it out if you're into video cards, GPUs, and especially if you're building computers and into the used parts, which is the best way to build computers. The smartest way, the best way. So many values. Look at that FPS. The video RAM utilization indeed right now is 24,000. Before it was a little bit less than that because I believe that we offloaded a lot of data into the system RAM. But the system RAM, as you saw, was below 10,000 megabytes. So the actual system RAM utilization should be below 10,000 megabytes. And when we went above 10,000 megabytes, that's a clear sign that we offloaded that amount of data. Instead of loading it into the video RAM, we loaded it into the system RAM. Average FPS 14.9. Maximum FPS 18.1, minimum FPS 11.9, and this is a high preset 16K UHD with two Titan RTX video cards in two-way SLI, running stock 100% fan rotation, but Intel Core i9 overclock at 5.1 GHz with the 16 logical processors or 16 logical threads. Okay. And very aggressive DDR4 timing, which I believe faster than DDR4 5000 at CL18. But we're going to find out when I'm going to retire this system. That's why I'm wrapping up with this system. But the very important key, this is the first system from 2018 that is capable to run this game in 16K UHD. This is the very key. Okay, this is the first point of data in our benchmark as again towards 16K video resolution, 16K gaming, 16K gameplays, 16K video resolution benchmark vector direction. Alright, so we got it. So what I'm gonna do next we're gonna change to medium. Okay, it's applied. As you can see, the character is not so detailed now. It's kind of squarish, not roundish, because I believe it's not using the tessellation. Oh, it's still using the tessellation. What is the tessellation for those who's not aware? Tessellation pretty much is increasing the triangles, the polygons into the 3D meshes, 3D polygons. 3D meshes, 3D primitives, 3D models, whatever you want to call it. It depends to the game engine, depends to the 3D rendering technologies. And it's kind of, you can make through the tessellation, you can use the cube, and while applying 8x tessellation, it can become a sphere, okay, by adding extra edges to it, extra polygons, or extra triangles, whatever you want to call it. All right, so medium preset, but what we're gonna do, we're gonna go ahead and reboot just in case to clear our video RAM and system RAM garbage collector, so it's going to deliver a proper data. Look how small that Steam window right there. So this is the licensed Steam version, and I gave away some Steam licenses and some GOG game client licenses for free, as again throughout my videos and throughout the holidays in 2020-2022. So that's another reason why you want to subscribe, guys. One day you're gonna be a winner over my YouTube channel, some nice giveaway that you don't want to miss, and a lot of information, computer science provided to you. You don't miss. This YouTube channel is a must to subscribe. Smash that subscribe button, share it with your friends, guys. You're gonna learn a lot beyond and above and beyond the gaming. Okay, full screen. Here we go. Everything 16K UHD. Alright, medium preset, untouched. Benchmark. 8K UHD, guys, is absolutely amazing, playable, comfortable experience on two Titan RTX SLI. It's just crazy. As again, this is the last moment, the last dinosaur, and pretty much the fastest computer that is capable to support it, running it as a gaming computer. Because in the future, SLI is not going to be supported, and the motherboard is not going to be certified that, and most likely Nvidia driver is not going to enable it. Otherwise, you can tweak it, but by default, Nvidia driver most likely on the future motherboards with the Gen 13, Gen 15 CPUs, which will be crazy, twice almost faster Gen 15 than my Gen 9 CPU by Intel, but it's not going to be certified. But if it's going to be tweakable, then you can still test it and deliver a little bit higher performance. You can utilize your both GPUs at 99%, and this is when it means it's fully utilized all the CUDA cores, all those Turing GPU architecture CUDA cores, without any idling of them. All of them, which is 4608 CUDA cores per video card. Anyway, 16K video resolution, medium preset, 2 Titan RTX and SLI, i9-9900K at 5.1 GHz per core, average FPS 18.7, maximum FPS 28.6, minimum FPS 14.0. Alright. And as again, because I'm recording with Nvidia Shadow Play, you can add 1 FPS to the FPS kind of maximum, that's all. Let's go ahead and change the preset now, guys, and as you can see, while we're changing the preset, the video RAM going down, the system RAM also going down, so low preset now. Okay, and then I'm gonna demonstrate for you the lowest, and we're gonna go ahead and wrap it up at this point. Okay, low preset. It's flickering a little bit now in full screen. That's why I love to run the games in windowed mode or borderless full screen, because it's not flickering. And under 16K UHD, a lot of games are flickering in full screen. Somehow shares the flickering. Under DirectX 11 and even DirectX 12 API and Vulkan API as well, I saw, and OpenGL I saw a little bit in some of the games. Not all of them, but in some of them. It somehow related to the mouse movement. Keep that in mind. Let's go ahead and reboot it. So let's go ahead and have a look. Is it going to be playable experience? Is it playable? I'm just curious. Beautiful. Please watch this video on 8K UHD, guys, to see all the amazing pixels, or 4K UHD as minimum. Switching your YouTube player. Alright, so here we go. 100%, 50,360 by 8,640. no limit on FPS, full screen, advanced options, low preset, untouched, without the tessellation. Now you can see the problems, and also the textures, the way it's loaded without some details. So it's blurred out the textures in terms of the artificially, in terms of the pixel count. So it didn't load the old pixels. It skipped some pixels. So it's going to utilize the lower video RAM while doing so. But of course, if you're running above 8K UHD or even 8K UHD video resolution, you want to maxed out your textures. You want to make sure your texture maximum possible visuals, so you're going to deliver the benefits of the 8K UHD and above. But this is a benchmark, and we're benching at all kind of different presets. That's crazy, guys. Medium preset was on the single RTX 20 on single Titan RTX and Xeon i5 2697 V2 at 3.5 gigahertz with only 4 cores. It was 11 FPS at medium preset. So two Titan RTXs, but that was running 16x. Two Titan RTXs is definitely beneficial, guys. It's almost 2x in terms of the performance versus single Titan RTX. I would say 1.7, 1.8x due that first video card is overheating and thermal throttling. Okay, when you're running single Titan RTX without the secondary video card, it's gonna breeze the cold air, and you can also overclock it as well. Or just put the get a water cooler AAO on it, but you gotta invest as minimum $130. $30 or $40 will be extension, and then buy at least 260 millimeter Corsair AAO or any other brand and mount it on your Titan. It's gonna cost you around $140. But I advise you is again, better sell those two Titan RTXs and do not invest that money into the water cooling AAO. All what you gotta do, just the first video card closest to the CPU, while the other one will be with the AAO will be running by itself 50 Celsius, never thermal throttle by itself. But invest that money towards the single video card. Single video card with much newer generation video card by Nvidia will be always outperforming, especially Nvidia doesn't support the SLI in 2023 and upcoming years. Keep that in mind. So average FPS 24.5. Maximum FPS 33.2, minimum FPS 16.4. And this was the low preset, two Titan RTXs and SLI. Intel i9 9900K at 5.1 GHz, 16 logical threads. Alright, that was great. Let's go ahead and switch now to the lowest possible. This is for those people that was asking me to test it as well under 16K video resolution, even if I didn't see the reason pretty much, but it's actually a great idea just to see how the CPU will reflect in terms of the data at the left top corner. In this high resolution at the maximum visuals 16K UHD, maximum 3D rendering in real time capabilities versus the lowest possible but still in 16K video resolution, which is 132.7 megapixels. Okay, lowest preset. Let's go ahead and reboot the game, and we're gonna bench it again. This is going to be the last benchmark. Look how small that Steam window right there at the bottom right corner. It's unbelievable. You can barely see it under 16K UHD. Guys, my voice can be a little bit disturbed because I'm using the artificial intelligence while removing the noise, because two Titan RTX using the Nvidia Founders Edition dual fan cooling system running 100% is kind of noisy. It's as noisy as single Titan X Maxwell's running 100%. It's not so noisy, but very noisy. When you buy video cards, always buy video cards with triple fans. Always. Do not buy with single. It's big taboo. Do not buy even with dual fans. Buy with triple fans. It's gonna run quiet and cool. Keep that in mind. Do not buy AAO, because AAO will last you 2-3 years and then it's going to run out and burn out the pump, and you're not going to replace it, so you're going to throw out the video card. While the air video card on air will last you 7 years as minimum, 7-10 years. That's another tip for you by UHDking. Trust me, I'm owning the 3D accelerator since Voodoo 3 2000. I know the business, okay? Alright, video. Same thing, unchanged. This is for those cuckoo nunus, naysayers, haters. Alright, lowest preset untouched. Let's go and have a look. It's nice to see the GPU utilization at the lowest possible preset versus the CPU utilization. But the higher resolution the last CPU is utilized, keep that in mind. So the last CPU cores you need at the higher resolution. This is the rule that I find out before anybody did. Linus, JZ2 Cent, all of those kukununus. I find out about it in 2016. And they are saying about that in 2020. They started about that. And in 2023 they saying about it loud now. But they learned it from me actually, guys. Look at that, excellent, almost excellent GPU utilization, almost at the lowest preset. That's incredible. But still, we cannot utilize two Titan RTXs. While two RTX 2080 Ti Turing GPU architecture was no problem to utilize on the i9-9900K at 99% in a lot of games, but look like two Titan RTXs, which is 512 CUDA core more as summarized than two RTX 2080 Ti, because 256 CUDA cores more per each video card on Titan RTX versus RTX 2080 Ti. It's impossible. The i9-9900K is not fast enough. I think it's going to utilize it with much newer generation of the CPU with higher instruction per clock for same frequency, or if you're going to improve the impulsing to the CPU of the data while overclocking it. It's called overclocking for those PC overclockers. But I think to be able to utilize every single Titan RTX in SLI under this game, you need to be running i9-9900K at 7 GHz, and it's impossible. Today I'm running the maximum stable home safe environment, already on water cooling. So you need to have at least LN2, and LN2 most likely are not going to complete this benchmark. It's going to crash because most likely it's not going to be stable. Or it's going to be runnable, just a benchmark, and then CPU will be useless because you're going to destroy the chip. Anyways, average FPS 24.9, so without the recording is going to be 25. Maximum FPS 32.8 and minimum FPS 16.9. So 33 without the recording maximum, and minimum 17, and while average 25 without the recording. And this is the lowest preset. UHD, two Titan RTXs, i9-9900K, overclock at 5.1 GHz per each core, 16 logical cores, 16 logical threads. Hyper-threading technology is on, 8 physical cores is enabled. Alright, that's pretty much it, guys. Let me show you the gameplay. Let's go ahead and have a look at the gameplay. This is an extra bonus for those kukunonos. Go ahead and smash that like button. So continue story mode. Let's go ahead and have a look. I'm gonna play with mouse and keyboard, but this game looks absolutely amazing with the gamepad. By the way, I just purchased myself my first ever gamepad from the Xbox. Never used before Xbox or PlayStation gamepads as myself, as my gamepad. I used some PC gamepad before a couple times, and I do have it. But this is nice and solid. And I'm going to review a next game that is coming out, Lost Planet 3. And it's going to be in 16K video resolution for the first time. Look at this, how beautiful the game looks like. This game is amazing, by the way. Great visuals. And under 16K video resolution, look at this. At the lowest possible visuals, it's still looking unbelievable. Look at this. When you're looking at the distance, everything is so sharp and detailed, because this is the advantage of running games above 8K UHD. Let me use the zoom tool and Windows magnifier zoom tool. Look at this, every single pixel is there, and this is the lowest possible preset. Keep in mind the texture is not so detailed, but look how they detailed at the distance. This is just unbelievable. But of course the characters need to have some tessellation, because I can see the triangles in the characters as low as possible at the distance. It's probably limited by the distance, view distance, and if the enemy character at a higher distance, It's not loading a lot of triangles to it. But while improving the visuals, this is the lowest possible visuals as possible in this game. Keep that in mind. So, oh my god, I didn't play this game for a long time. It's beautiful. Lowest possible visuals, guys, 30 FPS, so it's playable experience. So Turing GPU architecture, not only benchable experience, I'm pretty sure that Quadra Pascal GPU architecture could demonstrate the benchable experience in this game in under 16K video resolution, because Pascal GPU architecture already was featuring 24 GB of video RAM. Of course, the FPS would be lowered, but you can do the SLI here with them, with multiple Quadras. But the playable experience to Titan RTX and SLI, I think to be able to, for Quadras Pascal to demonstrate here, equipped with 24 GB of video RAM, the previous GPU architecture do that. Titan X Pascal was only featuring 12 GB of video RAM and wasn't possible to run it. You need to have 4 Quadras, and I think the performance will be like almost the same, maybe like 48 FPS, something like that. But this is the first video cards to the gamers, guys, because Quadras cost like a car, like a used solid car, and 4 of them would cost like a new car, like $5,000 each. You can buy a Civic almost for that. Brand new Civic, keep that in mind. Not a used one, but brand new. Beautiful, guys. It's just, and this is the lowest possible visuals. This is just unbelievable. So I showed you everything what you need to know. Oh, look how beautiful everything is. So it's playable, not comfortable, but playable experience. With the mouse and keyboard, it's kind of stuttering because the milliseconds by that FPS at the left top corner is like above 20 milliseconds, and this game requires comfortable gameplay below 15 milliseconds. So below 50 milliseconds, it means that your FPS should be like 65, 70 FPS average, but above 60 FPS to receive that comfortable experience. Keep that in mind. Beautiful, beautiful, but still playable besides the benchable. Alright, so Goku, no. Alright, guys, so I'm gonna stop on that, and look like we're going to go ahead and wrap her up. And as again, this was the lowest possible 16K video resolution. And thank you so much for watching. Check out the video comments. Please positive comments, smash that like button, subscribe. A lot of time, money, energy is invested. Share it with your friends, guys. Support me. You witnessed 16K UHD, the maximum video resolution in this game. I'm the first YouTuber that actually showed you the native 16K video resolution. And let me close that and let me show you something. In the video comments in this game, I'm going to put quit. Yes, I'm going to put the related videos. Also, I'm going to put related videos on single Titan RTX in this game, and 2 Titan RTXs in 8K, 10K, 12K, 7K, 5K, 6K, and 4K. Single Titan RTX and 2 Titan RTXs in SLI, as well as future PC systems, future video cards, future CPUs, and future mobile devices even. Alright, so go ahead and check it out. Read the comments, and as again, positive comments, smash that like button. And an extra information before I will let you go. As a fact that 16K video resolution, not UHD, but 16K video resolution is the maximum renderable resolution by any open source or commercial APIs. So let me real quick go ahead and demonstrate it to you as a fact. And GPU. So under the Nvidia CUDA, 16K, XYZ, 16,384. This is the maximum amount width and height, or XYZ. And 2D textures can be 32K, and 3D surface 16K right here. But 2D layer surface size 32K. And this scenario applies to all APIs. Check it out. OpenCL, same deal. 16K max 3D image size, 32K will be the textures, okay? But 2D. Mantla, Vulkan, no matter what kind of API, open source or commercial, 3D 16K, which is XYZ, and 32K as 2D. And let me show you DirectX. DirectX API, here we go. Houston, we got it. 16K video resolution. Alright, guys. So pretty much that's it. Today you watch everything, you know, what you need to watch, and everything was demonstrated for the beginners as best possible as possible. Now you exactly know why my name is UHDking, aka I play 4K, aka I play 8K, aka I play 16K. Have a good morning, good day, good afternoon. Till the next time.